In this video, we will learn some applications of derivatives, specifically related with revenue, cost, and profit functions. The first application will be to study the marginal revenue. So if R is the total revenue function for a commodity, then the marginal revenue function is the derivative of the revenue function. A nice interpretation of this is the following. When x is equal to a, if the marginal revenue of a it's, let's say, equal to b, then the revenue function at 1 unit more will be approximately the revenue at A plus B. So this is saying that the marginal revenue at x equals A says that the revenue will increase more or less B when I sell one more unit. Let's see an example. So they're saying us that the price for a product in a monopoly market is given by a function f of x, then the revenue function will be given by the price times the number of units that I'm selling. So if the price is 20 minus 0.04x, then first find the total revenue function, and secondly find the marginal revenue for this product when x is equal to 20 and try to interpret this result. Pause the video and give it a try on your own, and then we will check it all together. So let's start by computing the total revenue function. So remember, the revenue function will be the price times the numbers of units you sell. So in this case, the price is given by the function 20 minus 0.04x, and we're going to multiply all that by x. So in the end, the revenue function will be equal to 20x minus 0.04 x squared. So this is our total revenue function. Now let's move to find the marginal revenue. So remember, to find the marginal revenue, we need to find the derivative of the total revenue function, which we already found it. It was 20x minus 0.4 x squared. So we need to find the derivative of this. So the marginal revenue will be equal to the derivative of the revenue, which is 20 minus 0.08x. And now the question is, well, find the marginal revenue when x is equal to 20. So we need to evaluate this function at 20, which will be 20 minus 0.08 times 20, and this is equal to 20 minus 1.6. So in the end, this is 18.4. That is the marginal revenue when x is equal to 20. So the interpretation for this is that the revenue when I sell 21 units will be approximately the revenue where I sell 20 plus 18.4. Of course, this is not exact. This is an approximation, but it's a really good approximation. So this is saying us that the revenue will go up by approximately 18.4 when I sell one more unit. So a good exercise is to find the actual increase and see how it compares with your approximation. Let's move now to the marginal cost. So as with the marginal revenue, if C is the total cost function for a commodity, then the marginal cost function is the derivative of the cost. And we can do the same analysis as before. So when X is equal to A, if the marginal cost of A is equal to B, then the cost of producing one more item will be approximately the cost of producing A units plus B. Let's see this with an example. So suppose that the daily total cost in dollars to produce X units of certain product is this function. So it will be 0.001 x cubed minus 0.3 x squared plus 32x plus 3,500, let's say, dollars. So the question is to find the marginal cost function for the product and then to find and interpret the marginal cost when X is equal to 30. So let's start computing the marginal cost function. So remember, the marginal cost will be equal to the derivative of the cost function. So in this case, this will be 0.003 x squared minus 0.6 x plus 32. This will be the marginal cost function. So now let's find what is the marginal cost when X is equal to 30. So the marginal cost was found in the previous part of the problem and was this function. So we now need to find what is the marginal cost when X is equal to 30. So in this case, we will just find times 30 squared plus 32. And this is equal to 16.7. So what this is saying is that the cost of producing 31 units, it's more or less equal to the cost of producing 30 units plus 16.7. Let's see if this matches the actual cost value. So we can compute that the cost of producing 30 units is equal to 4,217, and the cost of producing 31 units it's equal to 4,233.5. So the difference is about 16.5. So this was a really good approximation of the increase of the cost. Let's move now to profit functions. So the same with revenue and cost, the marginal profit will be the derivative of the total profit function. So let's see this with an example. So let's suppose now that we are working with a competitive market, so we must sell our products for $500 per unit. And also the cost of producing each unit is 200 plus X, where X is the number of units that we're producing. So the question is to find the total profit function and calculate the marginal profit when X is equal to 40 and when X is equal to 200. So to start this problem, remember that the profit it's equal to revenue minus cost, right? So in this case, the revenue will be 500, which is our price, times the units I'm selling, minus the cost. So the cost of producing each unit is 200 plus X, and that times the number of units that I'm producing. So in total, this will be 500X minus 200X minus X squared. So in total, our profit function will be equal to 300X minus X squared. So now let's try to find the marginal profit function. So the marginal profit, remember, was the derivative of P. So in this case, this will be 300 minus 2X. So we can find what is the marginal profit when X is equal to 40. So this will be equal to 300 minus 80, which is equal to 220. And we can find the marginal profit when X is equal to 200, which is equal to 300 minus 400, which is equal to negative 100. So let's stop here and try to find what is happening in this case. So here we have the graph of the profit function and also the graph of the marginal profit function. So this is the graph of the derivative of the profit function. So notice that when X is equal to 40, we are somewhere around here and the profit is increasing. So that means that the derivative is positive, right? In the opposite case, when X is equal to 200, we are around here where the profit is now decreasing. So this is graph here. The derivative is negative. And this makes sense because after a certain amount of units, the cost of producing them will be bigger than the revenue that we obtain from them. And the most interesting thing is trying to detect this point where the profit is maximum. So using studying parabolas, we know that this number will be 150. If you don't know this, don't worry, we will work on this a lot. And now try to find what is the marginal profit of when X is equal to 150. So remember, this was 300 minus 2 times 150, and this is equal to 0. So this will be around here. And this is no accident, and this will be the topic of next week, which is trying to maximize and finding maximum and minimums of functions.